Hello. As you may know, IPv6 Enhanced involves multiple protocol innovations such as SRv6, network slicing, iFit, BeerV6, and APN6. Today we'll be focusing on one of these key technologies, SRv6. Dr. Peng Shuping, Secretary of the IETF Spring Working Group and a protocol expert for Huawei's data communication product line, is joining us today to share details of the design of SRv6. Hello, Dr. Peng.
Hello.
Before we get into SRv6, let's first consider SDN, which has had a far-reaching impact on the industry. Proposed back in 2007, SDN has generated heated debate about its development path. Could you shed some light on this, Dr. Peng?
Of course. Let's start with OpenFlow. The purpose of OpenFlow is to implement network management and control in a centralized way, where management and control are separated from each other. As such, it aims to unify protocols. But, in truth, this is far too idealistic to be fully implemented. So the SDN evolution roadmap is more widely accepted, with its distributed plus centralized hybrid architecture used to solve problems on IP networks based on existing protocols.
Could you explain this hybrid architecture?
It focuses more on the management control capability balance between the controller and devices, without going to any extreme.
In the past, there was an attempt to combine SDN and MPLS-TE to deliver MPLS-TE paths in cooperation with a controller. This attempt failed. Can you tell us why?
The main reason is the management control capability imbalance between the controller and devices. This solution relies heavily on the controller for centralized management and control, whereas the devices are responsible only for simple forwarding. Given the limited management and control capabilities of the controller and the problems in the interworking between the controller and devices, the solution is hard to implement.
Is the rapid development of SR related to the development of SDN?
SR conforms to the SDN evolution roadmap, allowing the management and control capabilities to be well balanced between the controller and devices. So SR is an excellent embodiment of SDN.
MPLS underwent more than 10 years of development before it reached maturity. Later on, in 2013, SR was proposed. What was the industry's reaction at that time?
For a long time, the industry only focused on SR-MPLS. Although SR-MPLS is implemented in the data plane, similar to how MPLS is, it upgrades the control planes, such as simplifying LDP and RSVP-TE. Nevertheless, some MPLS advocates were opposed to SR-MPLS and thought that MPLS could be further improved to meet service requirements. However, right from the beginning, improvements were made to SR-MPLS, such as introducing global labels.
So, in those days, people focused more on SR-MPLS instead of SRv6. When did the actual development of SRv6 start?
The SRv6 network programming draft was submitted to the IETF in 2017, kickstarting the discussion on the network programming capability of SRv6. In the beginning, the intention was only to orchestrate IPv6 addresses as SIDs and encapsulate them into a SID list to form a programmable explicit path, guaranteeing the SLA. But SRv6 actually offers a multi-dimensional programmable space that supports multiple functions, including explicit path programming, SID programming, and SRH-TLVs. This meets the requirements of new types of network services much better. And as basic SRv6 features are progressively enriched, SRv6 will support more new types of network services.
There were heated discussions following the proposal of SRv6 network programming in 2017, similar to the situation when SR was proposed in 2013. How did we finally choose SRv6 from multiple technical solutions?
At that time, the main solutions were SR-MPLS over UDP6, SR-MPLS6, and SRv6. Of these solutions, SR-MPLS over UDP6 was the first to be ruled out. We believed it to be a transition technology and a combination of SR-MPLS and IPv6, meaning that its deployment on mobile transport networks would be complex. SR-MPLS6, which was already mature at that time, supports MPLS deployment on an IPv6 network and MPLS label distribution through IPv6 routing protocols. For this reason, many people were in favor of choosing it. However, we finally chose SRv6, thanks to its network programming capability.
Thank you, Dr. Peng, and thank you for joining us.